Hello friends, today I am here to discuss the chapter Is Matter Around Us Pure, with the starting of the topic physical changes and chemical changes from the back of the chapter. I am using this chapter like the opposite way around so that you understand better what is this Is Matter Around Us Pure chapter all about. So first I am going to discuss the physical changes and chemical changes. So physical changes are basically the changes that are reversible, that you can revert after doing. So if I take the example, what physical change I can do with this paper is that I can just tear it. So tearing of this paper into two pieces would be a physical change because it is reversible. You can put these pieces like this and you can just join them with a tape or a glue and anything. But if I burn this paper, would you be able to produce the same type of paper again after burning? It's not possible. So it's an irreversible change, and so it will become a chemical change. So a physical change is the one in which no new chemical there is the same chemical properties are there of the matter and no new substance is formed. In most of the cases, just the state of the object is changed from liquid to solid or from solid to gas. But in some cases, it might not be a change of state as well. But in a chemical change, it is an irreversible change in which there is a new chemical compound formed. And you cannot just reverse it back. And there are many changes in its chemical properties. Like if I take example of H2O, the chemical properties of hydrogen and oxygen are completely different from so-called H2O. Okay, so I think that you have understood the topic physical changes and chemical changes. So after this I'm going to tell you what is pure. You are reading this word pure in this whole chapter, and this whole chapter is basically about the purity of the substances. So first let me describe the word pure for normal people. If you ask your mother what is pure, she will say that it's not containing any adulterant, or it's not containing something harmful for us. It's the original material like it should be. But for chemistry, pure is a substance which has only one type of a material. If we take an example of H2O, then the H2O would be said to be pure if it's having the molecules only of H2O, not of anything else like nitrate or anything else. And if we are taking a pure sample of hydrogen, then it would have only the particles of hydrogen, not of oxygen, helium or anything else. So pure is in substance which contains only one type of a particle, be it any type, and it can contain one molecule as well. So to make it more precise so that you can understand that H2O is a molecule, and it has combined chemically to form a molecule with 2 atoms of hydrogen and 1 atom of oxygen. Now you might be thinking why I am considering this H2O and pure substance. It is a mixture of 2 substances, hydrogen and oxygen. But you see that after they are chemically combined, they show properties different from their so-called substances like hydrogen and oxygen. So it is pure. But if we take an example of, say, chalk powder mixed in water. Now you will also say that it's also a pure substance because it contains 2 particles which are mixed together. But they are not pure substance because it is showing the properties of chalk powder as well as water. If you just filter it out, they are filtered out. But if you try to break this H2O, you can only break it by electrochemical processes and not by anything else. And that whenever the mixture is formed, H2O, it does not show the properties of hydrogen and oxygen. But in the chalk powder's case, it shows the properties of the chalk powder as well as the water. So, and pure substances, hydrogen also I can take an example. And this I think I don't need to explain because this is an atom itself and it does not contain anything inside itself. So it is a pure substance. A pure substance is a substance which contains only one type of a particle. One type, be hydrogen, oxygen, anything. So I think you have got to know what's the word pure. So after this, I'm gonna go on to type of pure substances. So as I've already told you what are pure substances, now let me make it more precise. I'll go on to elements. They are basically the atoms and not the molecules. So in elements there is nothing to get more complex in it, and you just have one type of a substance, say it hydrogen, helium, etc. But I'm going to explain you that there are 3 more branches of this called element. So let's discuss about the 3 branches in detail. That is the metal, the non-metal, and the metalloid. So let us go on to the properties of metal first and remove all of this non-metal and metalloid from our concentration. So for your information, I'll tell you that metals are a good conductor of heat and electricity. So I'll just write a word good conductor. They are sonorous. That means that if you hit a metal substance, like I'm sure that this is some kind of metal, and if you just strike it, there is a sonoring sound coming. Actually, I'm not so sure if it's a metal, but if you hit a metal, there is a ringing sound coming, and that ringing sound is called sonorous, or the sonoring of the substance. So they are sonorous as well. Market, you must have seen those copper wires, etc. So you might be thinking, these are metals. How are they converted into those wires? That is actually the properties of the metal. And not only copper, the most ductile metal is gold. So you might be thinking, what is ductile? Ductile is actually converting of the element into thin wires. So copper wire, so we can say that they are ductile as well. And more if I go in detail, you might have seen that some are on the sweets. Sometimes you have some metal sheets upon them and they are edible. So you might be thinking that how such an element is converted into so much of thin sheets. That's actually also another property of metal, that it is malleable. It can be converted into very thin sheets. And gold is one of the most malleable metals in this, in this branch of so-called elements. So it is malleable as well. And most of the time it is in solids. It's not that it would be liquids or gases. Most of the time it's solid. But as always, there are exceptions to it. And so these are the properties of metals. And now let's go on to non-metals. So if I want to make you understand better what are the non-metals, I'll just not rub this portion off, but draw another portion so that you understand better. And here comes my non-metal. So if metal is a good conductor of heat and electricity, then the non-metal would be a bad conductor of heat and electricity. For example, if you put plastic in your electric circuit, then you would see that the current is not passing because it's not a good conductor of electricity. And if you put in something that is from where heat is to be conducted, then it won't work so good. That means that non-metals are bad conductors or insulators, but I'm going to use bad conductors because at certain average, when your electric voltage or the heat voltage is very high, sometimes they do pass the electric current or the heat current. Do not get confused in that. I'm just going to write bad conductors. And then comes the word sonorous. So this is a plastic, not a plastic, I'm sorry. This is a non-metal, I'm so sure about it. So if I hit it, I'm not getting a ringing sound. So of course it's not sonorous. So I can say that non-metals are not sonorous. Then comes the word ductile. If I try to convert plastic into thin wires, do you think I would be? I don't think so. Otherwise we would have used plastic wires. So, a plastic or a non-metal is not ductile. If I say in simple words, a non-metal is not ductile. So it's not ductile. And same thing goes for the malleable one. It's not malleable. And in most of the cases, it's not solid. Means there is an equal distribution amongst the three things, amongst the three states. It can be a solid, there are equal opportunities that it can be a liquid, and there are equal opportunities that it can be a gas. So, there's no, fixed state for non-metals. It can be any of the states. It exists in three of the states. And as you say that anything can be converted into three of the states. But if that thing is sublime, that means that it converts directly from solid to gas, then you cannot get into the liquid state. But yes, by changing the temperature of different things, as I told you in the previous chapter, matter around us and our surroundings, you can get the three states of the matter, of any matter. So it does not matter.